Hello and welcome to my talk, A Massive Leap in Host Discovery at NahamCon 2021. Let me first start with introducing myself. So my name is Patrick. I'm a manager of triage services at HackerOne. I'm responsible for hiring into the triage team, managing the triage team, doing training, and so on. I'm also a bug hunter myself, and I've been doing that for the past 8 years. About some of the bugs I found, I also wrote them down at my blog. And I'm also on Twitter, and you can find me there on @ITSecurityGuard. Before we get into the main topic of this talk, I just want to quickly ask the question. We all know why recon or reconnaissance is important, right? For those of you that are experienced in the field, the answer may be obvious. But let me explain it quickly to the people that have no idea what I'm actually talking about right here. Whenever you are approaching a target in bug bounties, you first need to find all the domains and subdomains that are belonging to a company. And why are we doing that actually? So obviously you want to be the first that finds that specific host. Because if you are the first, you're more likely to be the first that also finds the vulnerabilities that this subdomain is hiding for. We also want to find as many subdomains belonging to a company as possible, because the more we find, the bigger the attack surface gets and the bigger the possibility of finding a bug is. But we also want to find those exotic, those hard to predict subdomain names. The ones that developers use for testing their product, the development environment, the QA environment, the staging environment. And to do so, we usually have two methods of doing so. One of them is active scanning for subdomains, meaning you have a word list and you try to brute force common words and permutations. But there's also a second one, which is passive enumeration. And in this talk, I want to specifically cover this part because this is what I usually do in my bug bounty journeys. So let me quickly explain to you what passive discovery is or how it works. So usually you have companies like Security Trails, Census, and Spice who collect data from companies day in and day out. They store them all and they provide them to big corporations. The big corporations use this data to actually map their attack surface, and that's why it's there. As you can already tell, this is also pretty handy for bug bounty hunters, because what we want to do is to get an overview of what the company actually owns. There are actually quite some scripts out there that does exactly that. They query those those passive discovery sources, and the tools they're using for that work as follows. So you have your super recon lead tool, and you feed it with the domain. This tool then goes and gets all the data from the data sources, sorts them all, uniques them, and prints you out the results so you can use them further. So let's have a closer look into some of the most used tools for passive enumeration. I have put together this graph who links the used data sources to its tool. If you have a bit of a closer look, you can quickly identify that the usage of data sources is pretty inconsistent, and almost every tool there is uses a different set of data sources. However, by now you should also see the problematic part here. If you look at the overlap that those tools are generating, this is inconsistent, and the missing coverage of this is a problem. So, Patrick, I hear you ask, why is this such a big deal? So in my opinion, the problem here is that we see nowadays in so many tools that there is little to none consistency when it comes to the use of all available data sources. And let's be realistic here for a moment. Ideally, you want to use them all. You don't want to miss out on any data sources there is, Because remember, the more subdomains you're getting, the higher your chances get of actually finding a bug. And that's our ultimate goal. So if you ask me, there are two solutions here, and I'm about to present to you both. So the first solution that comes into mind when you think about how you can use those tools all together is obviously a solution that is involving Bash. And you can get all those tools from GitHub, clone them to your PC, and write a wrapper that combines them all and does the magic for you. However, you will have to use a lot of grep and cat and curl and, pipe them left and right. And in the end, it will potentially work and give you the results that you need. But what if I tell you that there is a far more elegant, more beautiful way of doing this, and one that I just discovered a few months ago, and I was completely blown away by it. And the solution I found is, ta-da, a mess. As some of you have already guessed from the title, I reckon. So, let me give you a very short introduction about what a mess is. If you want to get more information about a mess, there are a lot of talks out there that cover this far more in detail than I could ever do that. But for the sake of time, I just give you a very quick introduction. A mess is an information gathering framework. And the reason why I call it framework is because in comparison to other tools, AMS is so much more powerful and includes a whole tool set of different modules that you can use for your reconnaissance process. For example, AMS has an intel module, which can be used for intelligence to find out which IP ranges belong to a company, which email addresses, and you name it. But AMS also supports your basic subdomain discovery, your subdomain scanning. And as you can see on the right here, those are the data sources that are supported by AMS by default. In total, 42 of them. But not only that, it also is capable of doing brute force, several permutations, certificate grabbing, and more. But Patrick, I hear you ask, isn't AMS not just one of many subdomain enumeration tools that you've been talking about already? And that's a great question. But let me start by explaining why AMS is different from everything that is out there right now. So what most people don't take into consideration when comparing AMS is that it's not about the amount of subdomains that you're getting in the end, although I said that in the beginning, I have to admit, but it's also about the amount of correct, meaning resolvable subdomain. A list of 1,000 subdomains is pretty useless if you need to further check if they are even resolvable, and AMS does that all for you. AMS does post-processing. The results you're getting from AMS are precise and ready to use for your future hunting. Before I was using AMS, this task always costed me a lot of time because I was getting results from tools, but they were not accurate at all. They included wildcards, and most of the subdomains they found were not even resolvable or just pure trash. And as a bug hunter, you not only want to get the quickest results, you also want them to be correct. But there is something that I find even more exciting about AMS, and that's what I'm going to introduce you next. The AMS scripting engine. So, what is it? In short, AMS allows users to develop their own scripts that AMS will then use in its reconnaissance process. We have seen something similar already with Nmap and the NSE scripts. In order to do so, AMS is using a programming language called Lua. AMS is using those scripts to also implement the data sources that are already being present in the tool right now. So let's say you have ever encountered a problem with a data source that MS is using and you're not sure if it's working correctly, or they changed the endpoint that this script is using, you can simply go into the resources and the scripts folder in the AMS directory and just adjust it accordingly. But how is this useful for your bug hunting, you may ask yourself? And how does that solve the problem that I introduced earlier? So let me explain. Okay, so probably the most important functionality of the MS scripting engine is to include command line tools. If you have a closer look at the actual code, it is fairly simple and straightforward to understand. On the right side here, you can see how the actual code looks like to run a command line tool. You first need to define a name for your extension. In my case, I was writing one for the tool Asset Finder, and then you define the type of the script, which in this case is an extension. What you do next is also pretty straightforward. You create a function, you provide it with the arguments, and you simply specify the local command that the script will execute. In this case, I will tell the script to run Asset Finder with the argument of subs only and give it the domain variable. What's important to notice about command line tools and the scripts, and if you want to include them, is that the output should be only raw data. And that's why I'm using the argument subs only for Asset Finder, because that will give me a clean output of domains. What AMS does next is it waits for the tool to finish, takes all the found subdomains and reports it back to the enumeration process. As you can see here, there is a simple for loop that will go through every result and take them and provide them to AMS. Pretty easy, right? But you may also encounter situations where AMS does not support a given data source or no tool out there supports it yet. So what do you do about that? I will explain to that in the next slide. Most data sources out there usually work on so-called REST APIs. Usually you either query them using a GET or a POST request. What you see here on the right is not the entire source code to make the GET request happen, but only a part of it. If you want to see the entire source code, I have attached the link to the GitHub repository at the bottom of this slide. But to quickly cover the most important aspects of this script, first of all, there is a function called API URL, which you have to define in order to get it working. In the case of Project Discovery, this is the URL dns.projectdiscovery.io/dns and a placeholder for the domain that you're looking for. What's also important to mention is that the scripting engine supports authentication. So you can provide your own API keys inside the configuration script. Once that is in there, AMS will automatically take them and set the appropriate headers for the GET request. As a last step, similar to what we've seen in the terminal example before, it will take the subdomain names from the API response and report it back to the enumeration process of AMS. And as a last example, I want to show you how this can be done for APIs that only accept a POST request. And once again, this is just a part of the entire script, but it will give you the very basic idea on how to perform a POST request. First of all, we need to define the method. And in this case, as I mentioned before, this is a POST request and provide it with the necessary body. Once that is done, much similar as in the GET example, we need to define the API URL, which in this case is an example for the census database. Much like in the GET example, we can also easily use credentials to authenticate with the API. Before I show you some real-life examples, I just wanted to give you a quick heads up that whenever you're looking to build your own module, there are several pages in the GitHub repository of AMS which already contain scripts for the most used data sources out there. So if you need some sort of inspiration, have a look in there and see if you can build your own data source around it. It's pretty easy and convenient to use. But now let's go to the fun part. Let's put this all together and fire up the engine. So the way I'm doing is the following. I did create 4 scripts for different subdomain enumeration tools I found on GitHub: Asset Finder, Find Domain, GitHub Subdomains, and Subfinder. I've written a script for each of them and put them all together in a folder. The next step is to actually tell Amass how to use all of this. And the command for that is as follows. So first of all, we run Amass, then we tell it which submodule to use, in this case, the enumeration module. Then we tell it where the script location is. Remember where the ADS scripts are located. In my case, this is /root/tools/script. And then we tell it whether to use the passive or the active mode. And as a short explanation, the passive mode compared to the active mode will not do any DNS validation, so it will simply just spit out the results it is getting from the tools. The -source attribute will show you later in the output which tool produced which output, which is very handy for debugging. The -d is defined to tell Amass which domain it is looking for. In this example, hackerone.com. And the include just defines which of the scripts I wanted to include in my scan. And the directory will be the directory where Amass stores the results for me. So now I want to give you a little example on how this looks in action. As you can see, you get a debug message that for each of the scripts that it's loaded, it is saying, hey, I have started the script. And in the blue brackets, you can see which tool reported which subdomain, and the green text is obviously the subdomain it has found. Since I'm running a little bit out of time, I want to take a moment to recap the most important takeaways from this talk. Starting with the inconsistency problem that I have described in the beginning, we now have solved the problem of the inconsistent tools by combining them all in Amass. We have also found a simple way of including every tool that is out there in the Amass environment, and we have a centralized way of storing the good results. Plus, we have the DNS validation and all the other magic that Amass has to offer. Now, there's one specific part that is missing. As of today, Amass is not supporting every data source that is out there, but it is very much capable of doing so. And that's why I would love to ask the community to contribute to the project and to provide as many ADS scripts as possible. So if you found this content helpful, please consider to join the development of Amass and their tools. You can find their GitHub page right here on the slides. And there's also a Discord channel where you can join and have a brief chat with the core developers of Amass and ask the questions and whatnot. I've also released a project called Amass Tools on my GitHub, which basically just hosts the scripts I've been using in this presentation. However, I will also add more if I have the time to develop them. So this is an ongoing project, and feel free to contribute or fix any mistakes. I can also highly recommend you to follow Jeff Foley, who is the core developer of Amass on Twitter, as well as the official Amass channel, which you can also see here, because they both post amazing content. And that's it from my side, folks. Thank you very much for attending my talk, and enjoy the rest of NahamCon 2021. Bye-bye.